Siemens brings the electro-hydraulic drive principle into play. Hydraulic systems deliver enormous forces while consuming only little energy. They have proven their worth in millions of applications in the aircraft industry and in the fields of construction machinery and hoisting and conveying equipment. What's more, the hydraulic concept is very simple. Forces are transferred directly and fast with no need for using gear trains. As a result, only a few moving parts are required and there is hardly wear and tear. So why not make use of hydraulics to generate great positioning forces? This idea of Siemens engineers led to the development of acvatics actuators type SKD, SKB and SKC. And these are the components contained in the actuator's housing: console, cylinder, piston, oil pump and return valve, and as the key element, the return spring. The return spring is always compressed, enabling it to pull the valve stem into the fully closed position at any time without requiring energy from outside. The force produced by the spring reaches a maximum of 2,800 newtons, which is more than the world record in heavyweight lifting. The control valve is opened by the hydraulic system. The tiny pump pumps hydraulic oil from the suction chamber to the pressure chamber. The spring is further compressed and the valve opens. The small oscillating pump, a Siemens development, is the heart of the hydraulic acvatics actuators. With a power consumption of just 8 watts, it delivers positioning forces of more than 10,000 newtons, safely, reliably, and with no wear and tear. During the valve's closing movement, the oil returns to the suction chamber via the return valve, and the mechanical force stored in the return spring closes the valve. Oh, a power failure. This can happen, also in the case of a complex heating plant. No reason to worry. The design concept offers a spring return feature in a very elegant and straightforward way. Other types of actuators can only offer this facility as a costly extra function and with much lower positioning forces. And this is how it works. In the event of a power failure, the energy stored in the spring is released via a second return valve, closing the control valve within 10 or 20 seconds, with a force of 1,000 and 2,800 newtons respectively. Only Siemens can do this. In spite of low energy consumption, the actuator operates fast and accurately. Depending on the requirements, the running time is 120 or 30 seconds for the entire stroke, the resolution being less than 1%. The control signals required for handling the enormous driving forces are delivered by the newly developed Advanced Control Technology, or ACT electronics for short. Extensive automation and easy-to-understand control enhance flexibility and safety. Standard features: automatic identification of stroke and end position, simple diagnostics through LED status indication, selection of optimum control characteristics, can be controlled by standard control signals DC 0 to 10 volts or 4 to 20 milliamperes. Checkback signal indicating valve position. Forced control, for example, frost protection function. The following extra functions are available as options: adjustable starting point and operating ranges, for example for sequencing, or stroke limitation for output reduction. Signal reversal for motorizing valves with reversed operating action. More than 2 million electrohydraulic acvatics actuating devices have proven their worth in a wide variety of applications worldwide. Clearly, engineers and planners use the electro-hydraulic line wherever large amounts of energy in the form of high pressures and volumes need to be accurately controlled, where highest safety is a key criterion, and where comfort, service friendliness, and reliability are of great importance. Everywhere, with success.